Okay, welcome everybody to the next installment of the WEFI seminar series. We're happy to have Maria Roche here to present some work on IT and GitHub. That's how I'm going to summarize it. As a reminder, the format, we've got 40 minutes for the presentation. Feel free to use the chat. We have co-authors in the virtual room answering questions via chat and perhaps interrupting Maria for any in-depth questions. After that, David Chu will be presenting a discussion, and then if we have some time at the end, some Q&A. Other than that, I think we're ready to go, and I'll hand the floor off to Maria.
All right, well, thank you so much. Just let me share screen. Can you see my slides? Everything good? Okay, awesome. All right, well, first of all, I want to say thank you to the organizers for having me here. It is an honor to be able to present my work with Annamaria, Conti, and Chris Peukert, who are both here. So they'll be handling the chat questions. Make sure to ask really hard questions so that they get sweating a little bit. So the project I'll be talking about is on open sourcing and startup funding, which we examine in the context of GitHub. Now, just a brief note on the title. This was inspired by a conversation I had with a colleague of mine in the entrepreneurship unit. And her reaction to seeing our results was really, wow, they're beefing it up. And so with that, let me jump right in to kind of what got us thinking about pursuing this project in the first place. There we go. So the big question is, what really predicts receiving funding? And many of you in the audience have actually pursued this actively yourself. And what we know is that the team seems to be a really important factor. We also know that technology seems to be really important for receiving funding. However, we know far less about what it is about technology, here in this picture presented as the black box, that is really driving receiving funding. Now, naturally, there are a host of different aspects that could be driving this, but we decided, based on as a function of our own backgrounds and also the data that we had available, to pick this question, which is, what role does technology, and particularly its sources, play in raising funding? Put differently, our question is, do startups rely on open source communities as a means to produce and improve their own technologies to then ultimately attract funding? So this is where we're really stepping in. This is our question that we're going to pursue, and I'm going to talk to you about in what follows. Now, we got inspiration for how to address and think about this question from the open innovation literature that also highlighted some really important trade-offs and tensions. One is, well, innovation is widely understood as a process of really recombining knowledge pieces. The other thing is that innovation in isolation is pretty difficult, especially increasingly so. As such, embracing an open innovation paradigm, which uses internal and external components, seems to be really crucial for firms to advance their technology pipeline. The reason being that the number and variability of components, both of which are really fundamental for producing breakthrough innovations, increases by doing so. However, and this is the big but, open innovation can also heighten coordination costs, and as such give rise to appropriability concerns. And this is because firms do not control all of the intellectual inputs. Now, this trade-off between, as I mentioned, is especially important or relevant for technology startups, this trade-off between open sourcing and appropriability. And why? It's because of their youth and their small size, startups are more likely to actually gain by drawing from external sources of ideas, as I mentioned, because the components they have that they can access goes up. But they're also likely to struggle with the appropriability issues because now they don't really have control over the IP that goes into building their technology. So as such, solving this trade-off is really crucial for startups. Given that beyond the founding team itself, as I showed in the first picture, the underlying technology of a venture is an important predictor for success in financing. Now, before I go into detail of what we did, where the data come from, and all the little details, let me give you a brief overview or a preview of the results. So what we did is examine a sample of startups for which we were able to track their activities on GitHub. and estimating a fairly saturated fixed effects model, we find that startups increase their activities on GitHub prior to raising a financing round and then decelerate after. We find that startups intensify those activities that rely on external technology sources they do not control themselves, more than internal sources. Using machine learning methods to classify these GitHub activities, because there are a ton, and we wanted to make more sense of what's actually going on, we find that the most prevalent among these activities are related to software development, so the backend, data analytics, and integration. Now, after a startup raises a financing round, we also see, and this goes back to this trade-off between creating a technology pipeline, but also appropriability concerns, we see that the likelihood that they choose permissive licenses, think of the MIT license or the Creative Commons license here, significantly declines. All right, and with that, let me give you a brief overview of what will come in the next couple of minutes of this presentation. So I will next give you a better understanding of what the data are, because this is really a special setting, and the uniqueness of this data really allows us to ask this question in the first place. Then I'll walk you through our empirical approach, show you some of the highlights of our results, and then in the end, speak to how this contributes to the existing literature and summarize with some concluding remarks. Great. With that, I'll continue unless there are any questions that Anna and Chris think I should answer. Okay, awesome. I'll continue. So the data. The data consists of two main sources. One is Crunchbase, and the other is the GitHub archives. Now, the reason we chose Crunchbase is that it's particularly good in capturing information on startups that may have not been venture-backed or may have not even received funding. And so for our question, this is really important that we get a sample of startups that span very different types of investors and successes. And so with Crunchbase, we were able to find information on 165,000 firms founded between 2005 and 2019. Crunchbase also gives us information on the identity and types of investors, for example, including the total amount they raised, and also gives us information on the industries, the employees, and has very nice, which we'll need later on, the website domain. From the GitHub archives, we get the record of public GitHub timelines since 2010. We match Crunchbase firms to the GitHub organizations using these website domains, so the URLs. Now, what is GitHub? For those of you who don't really know what this platform is about, I'll give a brief description. So GitHub is an open source hosting platform for software development and collaborative version control, Git. It started in 2008, and by 2012, it already raised over 100 million investment by Andreessen Horowitz. And by 2018, it was acquired by Microsoft for over 7 billion. As of January 2020, it had over 40 million users, 190 million repositories, of which 28 million are public, making it the largest host of source code, or as GitHub likes to call them themselves, the place where the world builds software. There are also different types of accounts that are available on GitHub. So there are personal accounts and organization accounts. For the purpose of this study, we're going to focus on the organization accounts because we can link these to actual startups. Now, to give you some more detail of how we actually linked Crunchbase to GitHub, for those of you who are thinking of pursuing a project using this as well. So what we did is first we used a GitHub API to collect all organization accounts. From these accounts, as I already mentioned, we extracted the websites of the account owners. Using this, we were able to link GitHub organization accounts to over 10,000 Crunchbase company profiles. And then after matching these and linking these together, we gathered time variant information on the public events. So what we can actually see that's going on GitHub of all startups through the GitHub archive. This includes timestamp data on events such as pull requests and forks, related to all own or external public repositories with which an organization account interacts. Now, two things here. So the distinction between own and external, just to give you an understanding of what that actually means. So own are all the repositories that the firm, the focal firm itself controls. External are all the repositories that are outside of the control of the focal organization. So produced by some other firm, some other startup. Forks are that type of event when a focal startup copies a repository that another organization owns and just copies it and embeds it in its own source code. So just to give you an understanding of what these things mean. Pull, just translated into more lay terms, means that a focal firm makes very small marginal adjustments to source code of a different firm and asks them to actually integrate that into their source code. So just to distinguish these different types. Now, we further collect information on the creation of public repositories and the transitioning of private repositories to the public domain. And this is going to be important later on as we tease out the mechanisms. And this is just another type of event that we can observe. Now, in terms of the full sample of startups, there are two key variables I want to point out, and they're highlighted in blue here, is raising funds and GitHub. And as we can see here in the descriptive statistics, we have about almost 40% of the startups in our sample raised funds. And we see that almost 10% of the startups in our sample have a GitHub account. So just keep these numbers in mind. I already mentioned things about different types of events, distinguishing between external and internal. Here is a layout of the different types of events that fall under external and internal events. So I already mentioned what the fork event is. This is probably, if you think of an external event, this is probably the archetypical one that you should keep in mind, because 96% of the events that we observe are actually forking events. When we look at the internal events, there is a little more variation. Here, almost 50% are member events. That means adding new people to your team. So you're adding new collaborators into it who can work on the repository. Public event, as I already mentioned, is making something visible to the public. And and so these are probably the main events that you should keep in mind, just so that you have an understanding of what we're actually talking about when we speak of external and internal events. Great. Now, speaking of the startups that actually raised funds and have a GitHub account, these are the descriptive statistics. Let me give you a brief understanding here also of what we did here and what the numbers actually are. So here we averaged over a 12-month before and after raising a fund time span, the activities we observe. So just so it's a little odd descriptive, but this is going to be important because that's kind of what we're basing our analysis on. So just to give you an understanding, in this time span, almost 50% of the startups engage with a repository. 26% roughly engage with an internal repository, whereas about 43% engage with an external repository. Now, the next couple of variables here may look a little cryptic to you, so let me give you an understanding of what this actually means. So we further distinguish between, as I mentioned very, very early on, between the different types of activities that startups engage in. And here we distinguish between software development and backend, machine learning, API, user interface, and HR-related activities. Now, I will give you an understanding now of how we did that. So to do this, we implemented a combination of the TF-IDF vectorization and k-nearest neighbors prediction methods. We manually classified a subset of 150 repositories with the help of software engineers, because we're not necessarily software engineers, otherwise we would probably not be sitting here today. But so we got help and manually classified these. And then we used the k-nearest neighbors algorithm to classify the rest and iteratively expanded the training set. Maybe an easier way of understanding this is looking at this visually. Don't be blown away by all the words. This is just to show you what we did here. We clustered this into 5 different categories. So we had software and backend, as I mentioned, machine learning, API, user interface, and human resources. Some of these keywords may be familiar to you, such as TensorFlow or Slate. And so this is just to give you an understanding of how we classify these repositories. Now, I hope Anna and Chris have been able to answer all your questions in the chat. Anna, are there any substantial issues I should address? No, okay, great. With that, I will continue on and jump right into our empirical approach and some of the results we have. So our first step was to understand if GitHub is actually correlated with raising a funding round or financing round. Because if not, then that's where we're going to stop. Paper is not going to happen. We're done. So the first thing we did was trying to understand if there's a correlation. And as we can see here in the table, yes, GitHub does seem to matter. And the coefficient is similar in magnitude to having a top team member, like let's say high human capital. The top team variable is derived from Crunchbase's list of top individuals. And so we see both matter, right? And this holds even when we use an interaction and an alternative specification or definition of industry by using the number or the share of keywords, software keywords that are associated with a startup. And so over the different models, this seems to hold. That's great. Good starting point. With that, we can now actually ask the question whether and how startups actually rely on GitHub activity to achieve a funding round. And here, I'm just going to display our empirical specification below, and we'll walk you through what we're actually going to do in the next step. So here our model, Y equals to 1 if a startup engages in at least one public activity on GitHub in month T. This is also important to keep in mind as once we go to the table, we're really looking at monthly activity of a startup. So that's our unit of analysis. We then post equals to 1 for the 12 months that follow a startup's financing round and a 0 in the 12 months preceding it. Tau is a count of months to and from a given round. And again, I've highlighted two Greek letters for you, gamma and delta, which are going to be really important once we go to the tables. These are really our coefficients of interest. Okay, just to keep that in mind. We saturate the model with a host of different fixed effects to ensure that, for example, so we have startup fixed effects to make sure it's not something, so we're looking at really within variation of the startup. We also include age fixed effects. We also control for trends related to the industry or the location. And we also have a fixed effect for whether a startup raised a subsequent round. For now, we're going to focus on the first round, but I'll show you how things play out in further rounds as well, which is also very interesting. But I will ask you at this stage to be a bit more patient. We will also deal with other questions such as, is this all related to the technology lifecycle of a startup? Also in a couple of slides. So I'll just ask you to be a bit patient here and I'll show you the main results now. So what we find in terms of engagement in a public activity on GitHub is the following. And I know there are a lot of numbers, so I'll walk you through step by step. And remember, the two coefficients we're really interested in are gamma and delta. So what we see here in column 1 is that with every month, or with every extra month, there is an increase in activity on GitHub. And the post times tau coefficient tells us that after raising a round, there's a decrease. Now, to give you an understanding of what the magnitude on tau actually means, because this looks pretty small, but again, this is a month, right? Just for 1 month. If we compound this effect relative to the mean over time, this actually represents something around 50% increase. So although this may seem small, the magnitude of the effect is actually fairly large relative to the mean. And in this model, we're including the startup fixed effects. In the next model, as I mentioned before already, we're controlling for certain trends. The results are very similar. In the third model, what we do is we include an alternative specification to capture software, which is using the software share I mentioned before. In the third, we include age fixed effects because it may be something about the technology life cycle again that's going on. In the fifth, we include age times startup and post times startup fixed effects, which is a fairly strong, which is a fairly strong control to really get at what's going on within the firm, and it has something to do with this technology life cycle. Now, in the sixth column, this is here we include lead investor fixed effects. Note that the observations do drop because we were only able to identify the lead investors of about 65% of the startups, but reassuringly, these results hold. And if you compare these to, for example, the first model I showed you, they're actually larger, which suggests that when we include a more lax specification, this may actually be a lower bound estimate. Whereas when we include a stronger specification, the magnitudes of the results are actually larger. All right. Now, to show this graphically, because these are a lot of numbers, hard to say what this really, how should we think about this? I also plotted the results out. And what this shows is that this is not a linear relationship either, which is important to keep in mind. And so we see the strong slope just before raising a fund, around this increase, and then this flattening out afterwards. When we look at the distinction between the own and the external repositories, we find that most of these results are actually driven by the external activities, which is the line in blue, the solid line, whereas the internal activities are represented by the dashed red line. Now, the next step we did is to provide more evidence in terms of, is what we're really suggesting, it may just have something to do with the technology life cycle, we don't really know what's going on. So what we did here is we exploited an exogenous change in the relative price of accessing external knowledge. What happened was in October 2015, GitHub changed its pricing model from a repository-based one to a user-based one, which in the process meant that they introduced an unlimited private repositories for paying customers. This meant the price of internal collaborations went down, whereas the price of engaging in external technologies was the same. Now, to give you an idea of what this meant in dollars, in the before 2015, $25 would get you 10 private repositories. $50 would give you 11 to 20 private repositories. After the price change, $25, and this is all per month, will give you 5 users with unlimited repositories. And so we spoke to people who worked in the area and who experienced this change. And though this may not appear like huge numbers, they all, throughout, everyone we asked was telling us this was really a big change and changed how they actually collaborated and worked together on GitHub. Now, what the product manager actually said in an interview with VentureBeat was that this was the goal. Like they really wanted to make internal collaboration easier and more dynamic. Most importantly, and this was most important for us, this has nothing to do with the technology, the life cycle of a technology, but rather just with the relative price of external and internal knowledge, accessing external and internal knowledge. Now, to show you how this, the trends over time, I have a graph, a little complicated. So let me walk you through step by step what this graph shows. On the left-hand side, we see different types of internal activities. And here we're distinguishing between other internal and member events. Remember, I told you earlier that member events are those of adding additional people to your team. Other internal are all those other things that we saw, but focus on the member events, okay? On the right-hand side, we see the external events. And as we see, both the external and other internal events remain fairly unchanged over time, whereas the member events really picked up. There was a stark uptick right after the pricing change. Now, what happened to the engagement on GitHub before and after raising a round? What we see here in this graph is in blue, what was going on before the price change, in red, what was going on after the price change. And we see here that before the price change, internal member events were fairly flat. There wasn't much going on in terms of relative to and from the funding round. Whereas after this pricing change, you see a similar pattern to what we saw earlier, and this increase before raising a fund and a flattening out afterwards. In terms of the external events, we see, again, blue is before the price change, red is after the price change. We see that there's a relative decrease in these events, or if you want to speak in slopes again, the slope is somewhat flatter before raising a round. And so what we think this really suggests is that the use of external repositories or on GitHub hinges on this relative cost of internal and external, or accessing internal and external knowledge. Now, this was all, high level overall what we're seeing. Now, I mentioned earlier that we also classify different types of repositories. And this is where we also found some very interesting patterns. So when we distinguish between the different activity types, what we see, and here I'm just showing 4 of them because they fit nicely on one slide. We see that for software development and the back end, there's a similar pattern, this increase just before raising a fund around and then flattening out. Machine learning, we see a similar trend. For APIs, we also see a similar trend. Whereas for the user interface, the results do not hold. What this seems to imply, or this is how we interpret these results, is that most of the action is really going on in these aspects of the production function that really contribute to building the technology. Whereas the user interface is more something that has to do with beautifying your technology and not really in building the functionality of the technology. Now, building off of that, the next question is, well, is this just signaling? Are they just like doing things to show that they're not just an empty shell? Arguably, that could be a very viable alternative explanation, but there are 3 reasons why we don't think it's all about signaling. The first is what I just showed you, is that these activities are going on in the production, really in the core activities that like help produce the technology pipeline. The second one is we also looked at the README files, and these should be fairly easy to change. We all have done those before. If we've ever uploaded our data onto any website, we had our README files. They're very simple to change. We don't see any activity there in terms of before or after raising a round of changing anything in the README files. The third thing we looked at, and this comes back to the different activity types I mentioned earlier, is looking at what happens to making repositories public. Because this should be also a fairly easy way to increase visibility, because it's already there. All you have to do is make it public. So there's not much, it's fairly easy to do. So what we see here again, and here I've highlighted the coefficient of interest in blue, is that there's not really a change. So before and after raising a round, making a new or existing repository public is also is not sensitive to this, which speaks against taking all of these three different aspects together, which speaks against that this is just some sort of empty signaling, but rather that they're really using GitHub to create their technology pipeline. Now, as I mentioned before, there's another important aspect going on, and this important tension of really thinking about the trade-off between building or accessing these knowledge pieces, open innovation versus appropriability concerns. And here what we did is we looked at the type of licensing that startups used before and after raising a round. As you can see again here, and the coefficient of interest is the post times tau coefficient, which is highlighted in blue. We see that the licensing strategy evolves in the sense that there's a far lower likelihood of having a repository with a permissive license. This means those types of licenses where it's fairly easy to use, adjust, change, and reuse, these are far less likely to actually be used by the startup, which may suggest that there's something going on about after receiving a round of now, oh, maybe we should pay a little more attention to what we were doing with our licensing strategy and try to appropriate what we've actually built. So this is what seems to be going on. Again, this is fairly robust to different specifications and including different fixed effects and interactions of them in our model. Now, we also thought, okay, we've looked at different activities, we know baseline kind of what's going on, but how does this differ depending on different aspects of the startups? One thing we looked at is how does this differ by if they're completely ingrained and all their keywords that are associated with the startup are about software and those that are not completely related to software. And what we see is that the bulk of the effect is driven by those that are software oriented. Going further, and I already mentioned this at the very beginning, we also wanted to understand how this differs by round. And so what we did here is we split this up by the first, second, and third round. And as we can see is that in the first round, the effect is the strongest. The second, it still holds. And in the third, it almost disappears. So it's something about the first financing round where it's very, very important. We also find the strongest effects for VC-led rounds and when successful investors participate. And this is also a strength, and again, going back to why we use Crunchbase, because we can make this distinction. Otherwise, we wouldn't have been able to look at these differences between VC and successful investors. And here are the results for the successful investors, which for the lower 25th percentile is really flat. And for the upper 75th percentile looks similar to the trends we saw earlier. Now, with that, let me briefly summarize what we see and also tie this into the existing literature. So what we did in this paper was we investigated the role of open source technology investments among nascent firms in raising funds. We find that GitHub, first of all, is positively correlated with raising a round. We also find that GitHub activity increases prior to raising a round and then levels off. The results are primarily driven by the first round. There's more activity before VC-led rounds and when successful investors participate. Most activity or the most GitHub activity dynamics come from the forking of external repositories that the startup does not control. And this is along the full spectrum of digital technology so that remember the results I showed you where we distinguish by type. And startups are less inclined to choose permissive licenses after raising a round. Now, this also fits nicely to the conversation in terms of what are the sources of knowledge for innovation. And here, this is other data a different survey, the Mannheim Innovation Panel, which is a representative survey of German firms. But we thought it was really important to kind of tie this into the greater conversation of thinking about what do firms actually use as their sources of knowledge for innovation. And here we see that open source does appear to be a very important factor, even more important as deemed by these firms that were surveyed than patents. So this is just another contribution to this kind of thinking about what kind of knowledge sources do we use. Overall, this paper also contributes to open source and firm productivity, this whole literature and discussion. But instead, we focus really on these technology startups and show that they rely on external sources to develop their technologies and attract funds. Second, we also contribute to this debate in entrepreneurial finance on whether VCs invest in the jockey or the horse. To some extent, we're opening the horse and maybe looking at a Trojan horse if you really want to take the allegory that far. We show that above and beyond the jockey and the horse, relying on open source communities seems to matter. Thirdly, where we also contribute to is thinking about firm boundaries and innovation. This is particularly important. We thought this was kind of shocking if you think about that contrary to the common wisdom, that startups really fully control all aspects of their technologies. We really find that they extensively rely on external repositories to develop, scale, and integrate their technologies. And so we found this was a really interesting and key insight from this paper. And with that, I think I was a little fast, but I would like to say thank you for all your attention. I see that Anna is like very focused on answering the questions. So either David can take it away or I can answer some questions right off the bat. Michael, Song, what do you think?
I think let's let David take it over and then we'll have some time after. So
perfect,
David,
thanks.
The floor is yours. Thanks.
Okay, excellent. I'm going to start sharing
Perfect.
my screen. Hello, everyone. Thank you for the invitation. I'm hoping you can see my screen here with slides.
Yes.
Okay, terrific. Let me get started. I'm going to take, I don't know, 12, 14 minutes, hopefully maximize the amount of time that we have at the end for open discussion. Really interesting paper and project presented by Maria and team. Mainly I'm going to be making some comments about interpretation and where to focus and some kind of alternative ways to think about that. So just a quick context review here. This is a platform that is widely used that facilitates distributed collaboration and version control, issue tracking, mainly for kind of these developers in software development. And what's nice about this context is that, you know, I think it's appropriate. This is a company, GitHub, that's funded by Andreessen Horowitz, A16Z, famous for this Wall Street Journal op-ed, software is eating the world, and that certainly seems to be true. A nice feature of that, of course, is that software can leave a substantial paper trail, which allows the researchers to really kind of trace an aspect of business development and effort on the road to resource acquisition. They're mainly thinking about kind of financial resource acquisition. We're going to also have to revisit this concept of business development and whether that's the extent to which that's tantamount in some sense to software development. I'm going to kind of push a little bit on that distinction, but here is an opportunity to kind of at scale take a look at the kind of peel back the hood, take a look at what's going on here. So that's super, super nice. Here's a key finding. Now, this is just descriptive. This is not kind of post regression or anything, but I think it illustrates the key finding in the paper, which is around the, before the event time, which is the round of financing, the effort level or contributions that has a steeper slope, and then afterwards that tends to level off. Now, what if you, just kind of do this thought experiment? What if you relabel the y-axis not, repository engagement or whatever, and instead look at things like a completely different empirical setting, like, number of papers published, up through the time of tenure, before and after. And, I would have a kind of a big guess that it would look something like this. Or if you took another big context, like, right around the time that you get married, how many date nights do you have? And you have a really steep slope, and then it just kind of trails off. And I think that just kind of illustrates this phenomenon of, to what extent do we expect something different, given that the incentives, effort levels are a little bit different pre versus post. I'm going to sharpen that up, but one kind of thing that I want to think about that is hand in hand with this comment is, how should we think about counterfactual trajectories? And I'm going to kind of push a little bit about the sampling that is employed here so that we can sharpen our thinking about those counterfactuals, while knowing, of course, it's hard to guess exact intent, and there could be heterogeneity on intent across participants on these platforms. Now, the other thing I'd like to just kind of point out is, there's a lot of concepts that are invoked in the paper. And in some sense, I mean, this is, I think that largely the authors are thinking probably about mainly about point one, maybe point two, but there's a lot of ingredients here in this paper, and it's ambitious. I love the ambitious nature of it. But at the same time, it kind of detracts a little bit from kind of where, as the reader or the audience, we should really be thinking about the key takeaways here, because there's a lot of, in some sense, disparate large literatures that are kind of being invoked, as illustrated here. And so, I would say perhaps decide what is the first order stuff and what's the second or tertiary kind of stuff, and drill a little bit deeper on kind of how the empirical contribution can kind of line up with a stronger kind of deeper kind of framing here. Just a reminder of the sample. So they take, kind of Crunchbase, that's a lot of companies, 160K companies, but the focal sample that they examine are these startups raising funding and who have a GitHub account. That's around 10,500 observations. And then of course you have the monthly observations plus and minus the 12 around the startups observation. So that gets us up to about 250K observations. Now, here, notice that they're focusing on that particular quadrant of the intersection between GitHub and funding. I think a natural comparison group would be those startups that have a GitHub account but do not seek or are unable, and I think this is kind of brought up a little bit in the chat that I was glancing at before, maybe this control group of startups not raising funding and who have a GitHub account could be quite important as a counterfactual or comparison group that could lead to a more kind of traditional type of empirical specification. Or to think about another quadrant here, you could actually think about startups who raised funding but did not have a GitHub account, because I think that there is, while GitHub is certainly probably the most well-known household name here for this kind of function, increasingly you have these other competitors like GitLab, OpenAI, and if I had to speculate, maybe that change in the funding model there that the authors identified in 2015, that might be related a bit to the 2014 founding of GitLab. And then there's other things as well. Okay, so thinking about the sample a little bit, I think is important. Another kind of like sample selectivity type of comment here is kind of this question: why do some firms make their code open? I think that there's kind of an older debate about this, but here's just one illustration to give you an example of that selectivity. This is the GitHub account for Apple, and they have 137 repositories. And if you kind of drilled a little bit or just kind of peruse this a little bit, you would recognize that almost everything there, the most used topics and repositories, they're all on this kind of learning to code, this kind of Swift platform. And there's very little outside of this Swift. And I think that kind of then leads us to think about, well, it's not just kind of just random or accidental that firms kind of make their code open, which leads us to this other question: why do some firms make some of their code open? And we have a couple possible explanations here. One is just kind of in the framework of selective disclosure in the presence of possible expropriation. Now, this Anton and Yao I'm invoking here is not in the context of kind of, reuse of code, but more about the classical kind of expropriation problem and thinking about possible design to mitigate that type of phenomenon. And so I think that beneath this, we have to kind of ask a little bit deeper about some of the implicit assumptions of wholesale rather than partial GitHub use and how we could empirically distinguish along the spectrum. Now, another answer to that question would be, when the open code is not on the critical path to the firm's core value proposition. I gave you the Apple Swift example, but you could think about this in a wholesale kind of business model type of phenomenon where, for example, Red Hat makes its money not from the open software, but rather on the support, et cetera, et cetera. And then, of course, there's this kind of, I've put on an early example of this, but when you really want to influence a technical direction, and that's a kind of first order concern that's more important than possible expropriation. I think there's many examples of this. I've just put up here the kind of Tesla kind of tweet or post on this, but you think fast forward in business history and you think about, well, why does Google put up all those tools? Why does Facebook put up all these tools? Well, probably one likely answer is they want to influence technical direction. The follow on here, which I think I saw a little bit in the chat, is why do some individuals make their code open? Well, lots of obvious reasons, because their manager said to put it up. Another is, I think, the origination of the GitHub platform to really collaborate and improve code with a broader community outside of the organization. But there's a whole host of other possibilities here, which is like the star coder, the most elegant code, really kind of showing off. And there we think about possible career concerns, signaling to the labor market type of information. I wondered, obviously these authors have done a lot on the data side, but there is this kind of people tab within GitHub that could be a possibility for future exploration along these lines. Now, I think now just kind of turning a little bit to the events themselves, I was really struck, these, obviously the authors recognize these events are clearly not equal. And I've put in blue box here what I think are the most kind of non-commodified, really telling type of requests, which is on both sides of the marketplace, incorporate, it's kind of like more of a two-way dialogue or interaction in which you're improving and you're making a request to kind of incorporate it into the source code. So I would really love to see a little bit more deep dive. I understand that the observations are much less numerous than the stock type of forking events or member events, but I think a lot of interesting action is happening on those events. The other one here, and this is shown obviously in the presentation, but there does seem to be this between the external and other internal events, this parallel trend, but for the member events, that seems to be nonlinear at this level in 2015. But if you broaden the lens there as to what's happening, that smaller red, that smaller circle there, that blue, it just doesn't seem to be that major in the kind of overall scheme of things. And then we see this replication of the same slope in the red and the blue. The big kind of open circle there, I'm guessing, is associated with the A16Z $100 million funding round. That really lifts, or the amount of external activities. And so I'd kind of like look at this stuff a little bit. I'm going to speed up a little bit because I see I'm running a little bit over. But just in terms of interpretation, in these external events before the funding, it looks to be, blue looks to be a little bit steeper than red, and they're separated there, and the 95% confidence doesn't overlap. I would love to see if this is driven more by the stock fork events, in which you're just kind of copying repositories, or more about these interactions, the push, pull request, et cetera, right? It's just kind of redeploying external code to improve the customer experience. Whereas on the red, the kind of internal, that seems to be a little bit shallower slope. Is there some evidence here of kind of developing the internal secret sauce that's going to lead you to possibly be more attractive to the external investors. I'm going to, but I thought about two different angles that I'm would be interested in seeing develop, the first one I've already kind of said, which is I'd love to see a decomposition of those events, like the one-way versus the two-way. And then the second one, I'm not convinced that this exploitation of this, pricing model is actually that interesting. Essentially, what the author shows that, a plummeting cost of internal collaboration leads to, or is associated with, more internal rather than external collaboration. I guess I don't find that terribly surprising. I propose some alternatives here, maybe to exploit the exogenous increase in external collaboration costs to look at the type of external interactions that are going on, et cetera, et cetera. And then, of course, there's the obligatory comment about, why does that pricing model change? I suspect maybe it has to do something with the competitive environment. Let me conclude very quickly here. Summary of suggestions, like sharpen the message. How can you better harness the pricing shock? And then could you make more use of this rich type of events out there? And I won't say much about this last slide I prepared, but I think it is something interesting to ponder, which is, to what extent is code by itself just becoming increasingly commoditized? Like, what is the actual scarce thing here? Because it's probably not functional code, otherwise that probably wouldn't be made completely open. And then particularly when we have increasing advances in this space, where there's no code, et cetera, and more kind of functionality just being made open, how do we interpret what we've learned here from this paper? And then I think there's this deeper question for the field of entrepreneurial strategy, which is, this is an instance of endogenous appropriation strategy. And there's heterogeneity within the sample on this, both, probably empirically, but also kind of theoretically, and just thinking through how we should interpret this evidence in the face of that choice point, and what we could actually learn from this empirical setup, I think, is food for thought for all of us. So thank you. Good job on this paper. I actually took more than my 15 minutes, so apologies.